So, hello, hi everyone. Welcome to the Student Brand. So, this is your Shiva sir. So, now we are discussing about electric current. So, in the previous session, I was completed session 9. So, actually, this is session 10. So, we are doing problems now. We are doing problems. Okay. So, let's start. So, question number, coming to the question. So this is very important question. That's why I'm explaining again and again, because so it will be helpful for you to understand. So based on this one, we'll be having so many questions. We'll get so many questions. Okay, that too. Resistance and resistivity related questions. Based on resistance and resistivity, so this question is very important. So based on that particular concept, so now I am writing on the board. Just check once, let me know the answer if you know it. So question number, so a 6 ohm resistance, a 6 ohm resistance wire is doubled, a 6 ohm resistance wire is doubled, okay, doubled on itself, okay, so doubled on itself. Calculate the new resistance of the wire, new resistance of the wire. So this is the question. One, check it. A 6 ohm resistance wire is doubled. A 6 ohm resistance wire is doubled. Okay. So actually it is like this. Actually this the wire is like this. Okay. So doubled on itself means it is folded like this. So if you are taking like this, so it is doubled on itself. It is folded like this. Understood or not? Now you can 6 ohm resistance. So I am taking this wire. So initial length is L and cross sectional area is A. Initial length is L and cross sectional area is A. Then on the this time resistance is, that is nothing but rho into L by A is 6 ohm. Okay. So R equal to rho into L by A. Understood or not? Now we need to find out. So when it is doubled on itself, length will become half and area becomes 2A. Length become half and area becomes 2A, right? So that time we have to find out R dash. So R dash is nothing but L dash by A dash. Sir, why you are not taking rho dash? Rho dash will not change because metal is not changing. Okay. So if metal changes, then rho may change. Okay, rho will change. But metal is not changing, right? Metal is not changing. So definitely rho will not change. Rho will be same. That is nothing but resistivity. Resistivity. So it will not change. Resistivity will not change. Now you can take, so R dash equal to rho into L dash by A dash. So initial R equal to rho into L by A is 6 ohm. Okay, so this is 6 ohm. Now you can take R dash equal to, they are asking to find out, calculate the new resistance they are asking to find. So rho into L dash equal to how much? L dash is nothing but L by 2 and A dash equal to 2A. Okay, then if you take rho into L by, so 4A. So then 1 by 4, so rho into L by A, then you'll get R dash equal to 1 by 4 into, so this value is 6, right? This value is 6. So that's why I'm taking. So now 6 by 4 is 3 by 2. That is nothing but R dash equal to 3 by 2. 3 by 2 is nothing but 1.5 ohm. Is it clear? Is it correct? So let me know the answer. Is it correct or not? Yes. So once again, a 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. So this is the initial wire. So area of the cross section is A and the length is L. R equal to rho into L by A. So that is 6 ohm resistance. So if it is off, if it is doubled on itself, normally this is the length of the wire. So it is doubled on itself like this. Then length becomes off L by 2. Okay. Length becomes off. Yeah, of course, Shivani. So length becomes half. Length becomes half and area of the cross sections become double. Length becomes half, area of the cross section is doubled. Okay, like this. So that's why R dash equal to rho into L dash by A dash. So L dash, if you are taking L dash equal to L by 2, A dash equal to 2A, you can substitute here. So L dash equal to L by 2, A dash equal to 2A. So if you substitute these 2 points, then you'll get the answer. So R dash equal to 3 by 2, that is nothing but 1.5. Is it clear? Yes. So don't worry about it, you'll do it definitely. Okay. So generally I will tell one point. In my point of view, exam is like a celebration. So I will tell to everyone, so to all the students, it's like a celebration. Sir, why you are calling it like it is a celebration? Because so remaining time people will not come. This many people will not come. Okay, no? So to one place. So different schools, different different people, so new ones, they will come together to one place. So like parents, everyone dropping, coming, going, and so like it's like a festival mode, like a celebration. Understood? So it's like exams are like celebration. That's enough. So you do practice before, there you'll write exams. That's enough. Okay. So take it like that. You have completed 2 exams. So I hope you are enough confident to write. So you are good always. You do good. Great. Okay, definitely. History will remember only winners, not losers. So be on winning mode. Okay, so definitely will win. So a total of 6 into 10 power 46 electrons flow okay, flow through a current carrying conductor current carrying conductor when connected connected through an external power supply for 20 seconds. Find the value of current in the conductor. So this is the question. Identify the given data. First identify the given data. Then you can use the suitable formula. First identify the given data. A total of 6 into 10 power 46 electrons flows through a current carrying conductor when connected through an external power supply for 20 seconds. Find the value of current in the conductor. How to find out? What formula we have to use? So N given, T given. Okay, so we have to find out current. Okay. So first, here you can identify the data. The given data is, say, total of 6 into 10 power 46 electrons. That is N is given, N. And through current when connected to a power supply 20 seconds, time is given T. Find the value of current in the conductor. Okay, so we have to find out the current. So for that, what you have to do? First you have to write the given data. That is N equal to 6 into 10 power 46 okay, electrons, and time is given 20 seconds. So we have to find out. Normally formula is I equal to Q by T. Q is, they didn't give, but Q equal to Ne, right? On one electron 1.6 into 10 power minus 19 coulomb. So sometimes they won't give this value. Okay, so you have to remember. So when I'm explaining this concept, so they won't give this type of this value, so you have to keep in mind. So I equal to Na by T. So now we have all the values, so substitute the values. So I equal to N equal to how much? 6 into 10 power 46 into, so E equal to how much? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 by, so time equal to how much? 20 seconds. So first identify the current, how much? So the answer is so I got this value. So let me know it is correct or not. 4.8 into 10 power 26 ampere. Calculation, so you have to do. So the best way to do the calculation, first remove these powers. Okay, subtract it. Then you can, so one more point also remove. Then you can multiply and divide with that. That is the best way. Okay, so instead of taking all and multiplying, so go with the easy way, simple way. Okay. And the next one. So one more question, easy, but we have to work out. So yesterday I explained. So from past, this question I didn't explain. Okay. So this is very very important. But sometimes they will give like this also. Okay. Check once. What is the answer? Right? Okay. So I'll go to the one more. A wire of given material having, so this is very important. So check once. A wire of a wire of given material having length L and area of the cross section and area of cross section. So area of cross section. So A has a resistance of 10 ohm. So what would be the resistance of another wire of the same material having length 1/4, and area of the cross section and area of cross section 2.5 A. So that is the question. So check once. A wire of a given material having length and area of the cross section A has a resistance. So resistance is given. Okay. So resistance is given. So try to identify the data. So let me know the answer. So a wire of given material. So the question is a wire of given material having length. Okay, so here, so you can see. So initially, so you can take given data. So that is, first one is L1 equal to L, A1 equal to A, rho 1 equal to rho, because so they mentioned resistance of another wire of same material. So you have to observe here, same material. Length is L, area of the cross section A, and the resistance is given R equal to 10, R1 equal to 10 ohm, right? Now we can take another wire of having length 1 by 4. Length is, so L2 equal to 1 by 4 L. Okay, 1 by 4th they mentioned, and area of the cross section A2 equal to 2.5 ampere, sorry, area. So normally, so A means ampere, right? So that's why I thought like that. So A2 equal to 2.8. So now we have to find out R2. So R2 we have to find out. Okay, so what we have to find out? So what would be the resistance of? What would be the resistance? So R2 we have to find out. So they are asking to find out R2. Okay, so then we know that the formula is R equal to rho into L by A. R equal to rho into L by A. Now R2 equal to, so R2 we can take, so initially this is also how much? 10 ohm. So R2 equal to rho into L2 by A2. Rho into L2 how much? L by 4 by R A2 equal to 2.5 ampere, right? Sorry, 2.5 A. Right now, R2 equal to, so rho into L by 4 into 2.5 A. So then you'll get, so 2.5 into 4, 10, right? 2.5 into 4, 10. Okay, so 1 by 10 into rho into L by A. Then you'll get R2 equal to, so 10 by 10, then you'll get 1 ohm. Is it clear? So you'll get 1 ohm, check once, is it correct or not? Is it correct or not? Check once. So that is the correct answer. That is the correct answer. Is it clear? Right. So going to the next question. So check once, you have to identify the given data first. First you have to identify the given data, then you can go to the formula, substitute the values, then you'll get the answer. Understood or not? So you must check whether given data is it in all, so all the units are there in one system or not, you have to check. All the units are there in one system or not, you have to check. Okay. So after that, okay, so next one. So I hope it is very clear. So we'll go to the next one. Next question. So very important question. Conversion. So some students ask about conversions, right? So related to resistance and resistivity. So now I will explain that question. Check points. So one more question. A copper wire has a diameter. A copper wire has a diameter. A copper wire has diameter. Wire has diameter of 0.5 mm. 0.5 mm and resistivity of 1.6 into 10 power minus 8 ohm meter. Full stop. So what will be the length? What will be the length of this wire? Length of this wire. So to make its a resistance of 10 ohm. Resistance of 10 ohm. How much does its resistance change if the diameter is doubled? Okay, so this is the question. Diameter is doubled. Okay, identify this question answer. How to solve it? Okay, just try to identify the question. First identify the data. Okay, first you have to identify the data, what exactly they given. After that, select a suitable formula. Okay. A copper wire has a diameter 0.5 mm. So here diameter. So identify the data. Identify the given data. So here, what is this one? Diameter. Diameter is given. Diameter equal to 0.5 mm. And the resistivity is given. Resistivity equal to 1.6 into 10 power minus 8. 1.6 into 10 power minus 8 ohm meter. So resistivity, right? And to make resistance of 10 ohm, this is a resistance. So how much does it resistance change if diameter is doubled? Understood or not? So first you have to write the given data. First you write the given data, that is, so diameter equal to 0.5 mm, diameter equal to 0.5 mm, resistivity equal to 1.6 into 10 power minus 8 ohm meter, 1.6 into 10 power minus 8 ohm meter, and coming to the resistance is 10 ohm, resistance is 10 ohm. So here you need to understand one thing, diameter is given in mm. Okay, so 1 meter equal to, this conversion is very important. So 1 meter equal to 100 centimeter, 1 meter equal to 100 centimeter, 1 centimeter equal to 10 mm, 10 mm. So then 1 meter equal to, because they given in mm, so they given in mm, right? So that's why I am taking, so 1 meter equal to 1000 mm, 1000 mm. So then 1 meter equal to 10 power 3 mm, then 1 mm equal to 10 power minus 3 meter. Understood? 1 mm equal to 10 power minus 3 meter. 1 mm equal to 10 power minus 3 meter. So just check once. So that too diameter is given. Diameter is given. So if you want to find out radius, so diameter equal to twice of the radius, then r equal to d by 2. So then r equal to d is nothing but 0.5 by 2. That is nothing but 0.25. So that is mm only. So 0.25 mm. Okay. So then what you have to do it? So just take this one and multiply with that. Then r equal to 0.25 into 10 power minus 3 meter. So here 2 zeros, still we can write 0.25 into, so 25 into 10 power minus 3 we can write 25 into, so we can take 25 into 10 power minus 2 into 10 power minus 3, then you will get 25 into 10 power minus 5 meter. So that is radius. So radius of curvature, radius 25 into 10 power minus 5 meter. Understood or not? So that's enough. Now you can check here. So I hope you can rub this one, can arrange. Yes. Then radius given. So radius you got, resistivity you got, resistance you got. Now formula is R equal to rho into L by A. R equal to rho into L by A. So we have to find out how much, right? First we have to find out length, we have to find out. Resistivity is given, resistance is given. Area is pi r square. So area equal to pi r square, right? Area equal to pi r square, r is given. So pi value is 3.14. 3.14 pi value. Substitute the values, then you will get the answer. R equal to R10. Then rho equal to 1.6 into 10 power minus 8. Length we have to find out. Area of the cross section is 3.14 into 25 into 10 power minus 5 whole square. So like this. Okay. Then L we have to find out. Length we have to find out, right? So L we have to find out. For that, so L equal to 10 into 3.14 into 25 into 10 power minus 5 whole square by 1.6 into 10 power minus 8. If you solve this one, so how much you'll get after solving that? After solving that, how much you'll get? So I hope you'll get, so 122.6 something. right? So try to solve it. So 122.6. So 122.6 meter, because we solved in meters only. This is 5. Okay, so this is the length we found. So now we have to find out resistance. R2 we have to find out. When, so how much? This is the second question. Only one question we did. This is the second question. That is, how much does it resistance change if the diameter is doubled? If the diameter is doubled, so how much it is changed? Okay, so that we have to find out. That we have to find out. Understood or not? So from this formula, so okay, so I hope it is very clear. So I am arising. What you have to do, you have to read the question carefully. Twice or thrice you have to read it first. After reading, identify the data. After reading many number of times, so it depends on time also. So in the exam hall, so after reading many times before exam, while you are practicing, you will get habituated to that. So terms, words, then in the exam it will be very easy, right? So R is inversely proportional. So here the diameter is doubled in the sense R equal to, normally D equal to 2R, R equal to D by 2. So substitute in that rho into L by pi R square, right? Pi R square. So in the sense, so rho into L by pi into R square, in the sense D by 2 whole square. Then rho into L by pi D square by 4. Okay. So we need the relation between R and D. So R and D's relation is inversely proportional, right? So R is inversely proportional to square of diameter. Even if this 4 goes up, so then it will become 4 rho L by pi D square. Yes or no? 4 rho L. Yes. Then you will get, so R is inversely proportional to square of D square, right? So then you will get this one. Then 1 by that we can write, we can conclude that R1 by R2. So here diameter is doubled. They mentioned the condition, diameter is doubled. So R1 by R2 equal to D2 square by D1 square, right? So if it is diameter is doubled, is 2 is D2 is 2D. Okay. So first diameter anyway D only, second diameter is doubled. So R1 by R2 equal to, so 2D whole square by D square. Then you'll get 4D whole square by D square. D square get cancelled. R1 by R2 equal to, so then you'll get 4. Right? So already we know R value how much? So 10 ohm. Already they given the value R equal to 10 ohm. Right? R equal to 10 ohm. Understood or not? Substitute the R value here. You have to substitute the value of R in this case. If you substitute the R value in this case, you will get R2 value. Right? So I hope you got this relation. Okay, so I am erasing this one. So now you can see R1 by R2 equal to R1 by R2. R1 by R2 equal to R1 by R2 equal to 4. R1 how much? 10. R2 equal to 4. R2 equal to 10 by 4. That is nothing but 5 by 2. That is nothing but, so 2.5 ohm. So they're asking to find the change. how much does its resistance change? So here only diameter is doubled. When diameter is doubled, what is the resistance? So now we have to find out the change. So initial resistance is 10. So initial resistance is 10. When diameter is doubled, the final resistance is 2.5. Change in resistance. Change in resistance. Okay. So then you'll get change delta R I am taking. Delta R, that is. So 10 minus 2.5. So then you'll get 7.5. So that is that much change. So change is 7.5. Change in resistance is 7.5. Understood or not? I hope it is very clear. So that is the answer. So for understanding I wrote. So final answer is 7.5. Change in the sense decrease. How much resistance? How much does its resistance change? Okay, I hope it is very clear. So if it is clear means you understand. If it is clear, you got it. Then we'll go to the next one. Okay. So next one is, so as I mentioned, every time when you are reading the physics question, compulsory you have to identify the given data. Okay. So next question. I'll give one MCQs, try to solve it. So this is very important MCQs. And this question also we have to solve. RP, R value. Okay. Question number. An electric bulb is rated. Electric bulb is rated. Electric bulb is rated. Rated to 20 volts and 100 volt and 100 volt. So when it is operated, when it is operated on 110, the power consumed will be, okay. So let me know. A is 100 watt, B is 75 watt, C is 50 watt and D is D is 25 watt. So try to identify the answer to this question. An electric bulb is rated 220 volts and 1000 volt when it is operated on 110 volt. The power consumed will be. So what is the answer to this question? So first you have to find out the resistance. Power is given and potential difference is given. Find out the resistance. Then when it is operated at 210, then you can operated at 110. Operated at 110, then you can use that resistance because so heat electrical bulb is same only, right? Bulb is same. Resistance also will be same. Understood or not? So now you can check once. So you can, an electrical bulb is rated 220 volts and 110 volt. So V equal to 220 volts and power equal to 100 volts. So V equal to 210, 220, power equal to 100 volts. Then so we have to find out, in this case we have to find out resistance. Okay, so we have to find out the resistance. That is common for the second case because same bulb. So we know P equal to VI, V equal to VI, for V equal to, I equal to V equal to IR, I equal to V by R, because we have only, so P into V by R, we have only voltage and resistance, right? So then we can substitute P equal to V square by R. V equal to how much? So V equal to 220. So V equal to 220, you can substitute 220 whole square by R equal to how much ma? R how much? Oh, R only we have to find out. R we have to find out, but power is given. How much is the power? 100. 100 watt. Okay, so then R equal to 220 into 220 by 100. Then you'll get, so 0, 0, 0, 0. Then 484 ohm. Understood or not? 484 ohm. Now, so the same resistance is common when the bulb is operated at 110. So same formula we have to use, P equal to V square by R. P equal to, this time we have to use this one, 110. 110 whole square, resistance same only, 484. 484. Then this time we'll get, how much is the power? I hope you'll get this one, 25 watt. Is it correct? Is it correct or not? Let me know. Okay, one more question. Electrical heater. So this is very important. Two conducting wires of same material of equal length and equal diameter are first connected in series, then connected parallel across same potential. The ratio of the heat produced in the series and parallel combination. Okay, one more question. Is it correct? So if it is correct, you can click on like button, no? If you like it. If you like the content, those who are watching, if you like the content, just click on like button. If you understood, if you don't have any doubts. Okay, so next question. Mm. Mm. How many 176 resistors in parallel? So these resistors are connected in parallel. Okay, so thank you so much for joining and attending and listening my class. This is our Siva sir from Student the Brand. If you like the content, if you like the channel, please do like, share, and subscribe to Student the Brand. So do well, prepare well for exams.